Okay, so how are we going to approach these problems? What we're getting now is just the surface variance of different morphemes, and we're being asked from those surface variants to figure out two things, right? A set of underlying representations, one unique underlying representation, a stored lexical form for each morpheme in a language, and a grammar that when those underlying representations are fed through the grammar will produce predictable facts about phonological distributions in that language. And we have to get all of that from just looking at the surface forms, and it's sometimes helpful to break this down into steps, where step one here is always going to be morphological segmentation. In order to get any of this to work, you need to know the surface forms or variants of a particular morpheme. So in German, we saw with this stem allomorphy case, a bunch of morphemes that don't alternate at all, like the one for word. It's Wort in this context, it's Wort in this context. And so that's one kind of morpheme here. And we also saw some other morphemes that do alternate. For instance, this one for murder has a final voiceless stop in this context, but a final voice stop in this context. So the first thing to do is to collect all of the surface variants of all of the morphemes in the data set. You then need to, of course, identify, are there alternating morphemes? If not, then there's nothing to solve. That's great. Are there non-alternating morphemes? In German, we had both. In most cases where we're looking at stem allomorphy, we're going to find both kinds of morphemes, alternating and non-alternating. It's going to be a little bit different when we look at affix allomorphy. We'll do that in a second. So you need to identify the alternating and non-alternating morphemes. And then we need to figure out whether and where the predictable phonological facts are. Where do these different variants occur? And I've already organized that with just this sort of minimal pair of morphemes in German. One context we looked at in the left column was at the end of a word, and another context that we looked at in the right column was phonologically before a schwa, right? Or really this extends to before all vowels, but for the set we looked at, it was just before a schwa, that final plural morpheme. So these are phonologically different contexts. And we just list out for each one of these which surface variants occur in that context. Right? Now, we need to figure out the direction of change. In other words, what's the predictable phonological context, and what's the predictable phonological information? Which context is it predictable in, and which context is it not predictable in? Right? Which allomorphs here are conforming to a predictable distribution? And here, this is predictable. All the forms that we saw in that data set, in this context, ended in voiceless obstruents. What's unpredictable in that particular data set is this context, where some of these are realized as voiceless, some are realized as voiced, and there's no phonological way to predict the difference between these. Right? So for this class, it's always going to be the case with any kind of alternation that at least one phonological context here will have a predictable phonological information in it. So in the particular German example, word finally, the voicing property was predictable, but in this context, the voicing property was unpredictable. For affix allomorphy, and for maybe some other kinds that we'll look at in this class, it's possible that both contexts will actually be predictable. If that's what happens, then it's going to be a case of allophonic variation. But in the German case, only one of the two contexts was predictable. And so, again, following this general principle that we've been using all semester, the phonologically unpredictable information, which only emerges in this context and not in this one, must be stored in the lexicon. That's where unpredictable stuff goes. That's what the lexicon is. It's the place where you memorize things that can't be predicted according to general principles of grammar. Therefore, the voicing property, which is unpredictable in this context, must be in the lexicon. And this context is going to tell you what the underlying representations are like, right? Because this contains a lexical contrast that isn't visible in this context. Therefore, we better be getting our underlying forms from this context and deriving these forms by rule where they need to be, right? In particular, this context is revealing to us that underlyingly, German has a contrast between voiceless obstruents and voiced obstruents, and then we'll write a rule or a constraint or whatever that neutralizes that contrast in word final position. As a rule, this would say a voiced obstruent plus voice minus sonorant predictably goes to minus voice in the context of a following word boundary. The context-specific markedness constraint that we looked at just said, hey, don't have voiced obstruents at the end of a word. Either one of those is the start of an analysis of the system. But importantly, that means that this context is showing us the underlying representations, and this one is predictable from the phonological grammar. Let's try this again, but with a slightly more complicated example here. It's more complicated because it's going to be, again, a case of affixal alternations here. And this is involving the English past tense. This works exactly the same as the English plural, with a couple things that are different in the morphemes changing, but it's basically the exact same thing. So let's take a moment and try to go through these steps for the English past tense data shown at the bottom of page 3 here. The morphological segmentation part here is going to be pretty easy, in part because we all happen to know English pretty well. Although, you know, from this kind of surface transcription, we should be able to get this even in an unfamiliar language. And here we have a bunch of paired verb stems in isolation, like play, glue, plan, plant, like, sip, and wade. And then we have some past tense forms next to them. So play, played, glue, glued, tame, tamed, and so on and so forth. So the first step here is going to be to segment everything. Let's do that. So for instance, we want to segment these into their surface realizations, and then also distinguish between alternating and non-alternating morphemes. And if you do this, you will find that forms like play don't need to be segmented. Then we have forms like played, where it looks like the past tense is being indicated here with a voiced coronal stop. And what else do we have here? We have things like laugh, which again, there's no segmentation here. This is just a root. We have things like laughed, where again, the root or the stem doesn't change, but here it looks like we have a different realization of the past tense morpheme. And then we have a few like, what's a good one to look at here? Let's take wilt, which again is a single morpheme. It's a simple form, it's just a root. And then here we get wilted. And here it looks like the past tense takes on yet another form. So far, all of the verb stems that we've looked at are not alternating. There are a couple of alternating ones right at the end of this problem set, namely wait and wade. We're going to ignore those for the moment. This pertains to a totally different phonological generalization than the rest of these. But yeah, other than those, we don't see any alternating verb stems here, but this affix, which indicates past tense in English, this is definitely alternating. We have 3 allomorphs of this morpheme, and if you keep looking through the entire problem set, those are all the allomorphs you'll find for this particular morpheme, the past tense. Okay, so we've collected the surface variants of each morpheme here. We've identified the alternations, namely only this past tense suffix is alternating in these data. So this is going to be an affixal alternation problem. It's going to be a little bit different than the stem allomorphy or alternation that we looked at in German. Now we need to figure out where the different variants occur, right? And here we only have one morpheme to look at. So what are the contexts in which we get the voiced sound here? Take a moment and try to figure that out. Oops. Again, you might be able to just look at these data and figure out immediately what occurs where. But if you can't, the best way to do this is just to chart it out. So we found 3 different variants here. The voiced coronal stop, the voiceless coronal stop, and the schwa voice stop sequence. And we might just want to list the context in which they occur. Normally we do preceding context and following context. In this case, all of these are word final. So that's obviously not going to distinguish between them. We can just leave out the following context. It's the end of a word for all of them. What comes before each of these allomorphs? Well, d occurs after play. It occurs after glue. There's a length diacritic on that. That's probably not necessary. It occurs after fear, which ends in an sound. After fill, which ends in a l sound. We find this after n in planned. We find it after v in saved. We find it after the in bathed. Sorry, I messed that up a little bit. What else here? Used after a z sound. Rubbed after a voiced labial stop. Sagged after a voiced velar stop. And so on and so forth. How about this voiceless t allomorph? Well, that occurs after f in laughed. It occurs after s in missed. It occurs after sh in wished. It occurs after p in sipped, k in liked. And that's what we got so far. And finally, this third allomorph, ud, where does this occur? It occurs after t in planted. It occurs after d in landed. Same thing, t in wilted, d in folded. In weighted and weighted, this is sort of a clever example meant to show that there's another process that affects some of these stems in English, namely flapping, which turns either t or d into this so-called ballistic tap when it's in between 2 vowels, the second of which is unstressed. But in general, we assume that the underlying representations of weight and weighed end in t and d, even if it turns into a flap in this or a tap in this particular context. So those are also going to be cases of this allomorph occurring after underlying representation t or d words that end in those sounds. And now we've mapped out where do the different variants occur. The next question in our checklist here is the direction of change. So what are the things that we're going to derive from the grammar? In other words, which forms are phonologically predictable, which distributions are phonologically predictable. We said that at least one must be, for problem sets in this class anyway, and it's possible that more than one is predictable. In cases of affix allomorphy, like this one, where we're just looking at a single morpheme, it's very likely that I'm going to be giving you problems where it's predictable in more than one context. But let's take a look here. So can we come up with generalizations about where the d form occurs that separates it from these 2 forms? Well, what do all these things have in common? I got one. Can you think of one? They're all voiced, including the vowels. So that definitely helps distinguish it from this allomorph, but doesn't seem to distinguish it from this one because this also has a voiced sound in it. Does this sound ever occur here? It doesn't. So if we were really trying to distinguish these two, we could say that this context would be following a voiced sound that isn't a coronal stop. Or yeah, that looks like it would probably work. That's a pretty complicated natural class. Let's keep going though. So there is some kind of a predictable difference between these forms. Let's start trying to do this. Can we even state this as a natural class? This is going to occur in the context of, we said it's going to be voiced. And then the second part of this was, it's voiced, but it's not a coronal stop. Do we have any combination of features that can say everything except a coronal stop? Not really. There's no real way to write that. We can write minus coronal, but that's going to also take in, it's going to rule out things like ra or la or the or za, so we can't put minus coronal in this natural class, because that is not going to accurately characterize the stuff that's in here. We can put, that's not a stop, we can put plus continuant or something like that, but that's going to inaccurately characterize this guy, because it can be a voiced stop, it just can't be a voiced coronal stop. There's actually no way to write this context using our distinctive feature theory as a single phonological context. That's a good clue that this is probably going to be an elsewhere context. If you can't write it out using distinctive features, then it's very likely that it's the elsewhere condition, which in the case of rules, you're just going to not include in the rule. You're going to say, if we're in this elsewhere context, then the specific rule we'll write for these guys doesn't apply here. In OT, this is going to be handled by some sort of a general markedness constraint. Right? How about this one? What do these all have in common? This one should be pretty easy. They're all voiceless obstruents. And in particular, they're all non-coronal voiceless obstruents. Can we write that? Voiceless obstruents and perhaps non-coronal ones. How about this context? Just t and duh? Well, they're both coronal stops. Minus sonorant, minus continuant. So here are phonological generalizations. Let me add a question mark here to show that we had some trouble there. And we've now figured out which allomorphs are conforming to a predictable distribution, right? And which ones are less predictable, and that's going to determine what kind of a grammatical rule we need to derive the predictable stuff. So starting from this side, we're finding that before a coronal stop, this past tense is realized as a schwa-da sequence. Before a non-coronal voiceless sound or voiceless obstruent, it's being realized as a voiceless coronal stop. And elsewhere, it's being realized as a voiced coronal stop. Given that we couldn't describe the context in which this variant occurs, and we decided it's probably an elsewhere form, if it's the elsewhere form, it must be the underlying representation. That's a general principle in phonology. So if we think that the form of the past tense, the underlying representation in the lexicon, is duh, how are we going to get these other forms to come out? Well, if you put this voiced coronal stop after a voiceless obstruent, what would you need to say about that? It becomes voiceless in this context. Does that make sense? Yeah, we can write that as the rule, plus coronal plus voice minus sonorant minus continuant becomes minus voice when it's following this context. That's a perfectly good rewrite rule. We also had a constraint in English already that we looked at that would help us with this. It said that if two obstruents are next to each other, minus sonorant, they must agree in voicing. So that would actually automatically handle this as well. What about this context? Well, we'd have to say that this underlying voiced coronal obstruent, what happens to it? Well, you add a schwa in before it. Where do you do that? When it's following another coronal stop. So this rule would have to be something like change nothing into a schwa when it occurs in between two coronal stops. Well, there's your rule. Turn nothing into a schwa when it occurs in between two coronal stops. This is referred to as epenthesis in phonology. It's insert a sound. Here we're inserting a schwa in between two adjacent coronal stops. Here we're changing the voicing of the underlying past tense suffix when it's following a voiceless obstruent that isn't a coronal stop. And here we do nothing. We just let this underlying form surface faithfully in these contexts. So that's an analysis, actually. This is, in fact, the standard analysis of the English past tense. If you look at plurals, you'll find almost exactly the same thing, except, of course, the form in which you get the schwa inserted is going to be after a sibilant fricative, or actually after any strident fricative or affricate, not a coronal stop. So this seems to have something to do with the similarity between the suffix and the thing that comes before it. If you change the suffix to be a s, z kind of a suffix, then this happens after s and z and sh and ch, rather than happening after t and da. But otherwise, the plural situation is more or less exactly the same in English. What if we tried a different way of doing this? Well, we assume that this was the underlying representation. We'd still need a couple rules. We'd need a rule that changes it to voiced when it follows a voiced obstruent, except that's going to work for all these sounds. That will also apply following a coronal stop. So we're going to need a more specific rule to do something else in this context. We're going to say, well, there's one rule that inserts a schwa if it's following another coronal stop, but so far that would get us forms that end in ut, not in ud. So you'd have to say, first insert the schwa according to this rule, and then do the voicing rule when it follows a voiced sound, whether that's these underlying ones from the verbs or the schwa that we've already added in here. This is a totally different kind of a theory where we have rules in a specific order and they have to be applied one before the other. That might not be wrong, but it's a lot more complicated than the version where we assume this is the underlying form. The last possibility would be to assume that this is the underlying representation. And then this is going to get pretty weird. We're then going to have to assume that you delete the schwa. Right, what would you need to say here? You need to say turn the schwa into nothing if you're following a sound that isn't a coronal stop. And I'm not sure we can even write that using natural classes. So everything that isn't a coronal stop is not actually a natural class in our theory. That's a good clue that you're on the wrong track if you're starting with this as your underlying representation. So in addition to the steps that I've put in the handout here, it's sometimes worth also understanding what would happen if you made different choices about the underlying representation. Here, it seems pretty clear that this is the best choice and results in the easiest theory of this particular suffix alternation. Similarly, in German, we ended up deciding that the allomorphs from the plural form must be the underlying representations, and there is a devoicing rule word finally. If we'd chosen instead to make the isolation forms, the singular forms, the underlying representations, then we'd need to have a voicing rule that applies to words like mort when it occurs before a vowel, as in morda. But if we'd done that, then we would predict that every single word in that data set should show voicing of a final stop when it's before the schwa, and we saw that there are some words in the set that don't do that. So this is my sort of shortcut to try to help you find the underlying representations. If you're having trouble figuring it out, you can also just try out different underlying representations, and often one of these choices will just not work. If any choice of underlying representation works, then good. That means that you found more than one solution. But in many cases, you'll find that one choice of underlying representation allows you to solve the problem, or allows you to solve the problem in a fairly simple form, while other choices of underlying representation either make it impossible to solve the problem set, or they give you a much less elegant solution. Something like, well, first we have a schwa insertion rule, and then after that we have another rule that turns things voiced when they're following a vowel or a voiced consonant. That's a pretty ugly solution. It's complicated. The solution here, we just say, hey, we can't have two coronal stops next to each other in English, so we add a schwa in between them. And also we have voicing assimilation, so if this is following a voiceless sound, you make it voiceless. That solution works pretty well. Adjudicating between these different solutions is going to be difficult in some cases. There's one more step you might want to do, and this is going to be really more, in a real phonological analysis. We're probably not going to go through this in problem sets or anything in this class, but in real life, you want to also pick an analysis that generalizes as much as possible. So if you're proposing a rule or a particular kind of constraint, or constraint ranking, you want to ask, well, can you see that somewhere else in this language as well, or am I just doing that for this morpheme? Now, it's possible that some morphemes just have different phonology than other morphemes, but we don't have any way to do that in our theory, and we'd much rather have a theory where all morphemes obey the same phonology if it's possible to do so. So another form of this question is, if there's more than one possible interpretation of these data, do the different analyses make different predictions about other words besides the stuff that we've looked at here? Right? And how could one test those predictions? In the particular case of English, because we happen to know all sorts of other stuff about the language, we can ask, do the proposed rules or the proposed constraints here make sense outside of the narrow context of past tense forms in English? The answer is, with this analysis, where this is the underlying representation, these do entirely make sense. Why is that? Well, we saw earlier that even in monomorphemic context, in contexts where you don't have more than one morpheme put together, English doesn't really allow mixed voicing clusters of stops. You can't have a voiceless stop or a voiceless obstruent followed by a voiced stop in English. That's ruled out by the voicing assimilation phenomena that we've already seen in English. Right? So it makes perfect sense that this would devoice after these sounds. We find that elsewhere in English. It's a general constraint in English that you can't have mismatched obstruents